All right, this video is going over your classifying equations assignment, which will require you to categorize each of these reactions into one of the types of reactions we learned in class. And in addition to that, you'll need to complete the equation and balance it with phases. So in order to complete this assignment, you'll probably want your notes. So I have a version of the notes here on the reaction types. You'll want your periodic table for the phases of elements and your ions list to get the charges of ions, and you'll also want your solubility table to get the phases of compounds. So in this video, we're going to classify the reactions using our notes. If you want a more in-depth description and overview of all the reaction types, there is another video for that. So what we're going to do is a few questions from this assignment. So we'll start with number 1 here. And the first thing you should do, so we're looking at this one, the first thing you should do when you're doing these problems is you first want to classify and figure out what type of reaction it is, because that will allow you to figure out the missing parts. So for example, in number 1, we have a compound here, calcium bromide, and then we have another compound here, silver nitrate. So we have 2 reactants and they're both compounds. So what we want to do is look through our notes and see which of these reaction types starts out with 2 compounds. So if we look through our notes, we can see synthesis. So synthesis seems to, remember the thing that classifies synthesis is that you have one product. Decomposition is classified by having 1 reactant. So that's not what we have here. We have 2 reactants and they're both compounds. Single replacement reactions, they do have 2 reactants, but one of them will be an element and one of them will be a compound. So it's getting close to what we have here. But if we look at number 4, double replacement reactions, these ones we can see you start with 2 compounds as your reactants. So we have a match for number 1 here. It's definitely a double replacement reaction. We don't know which type it is yet, but that's okay. We'll figure it out once we complete the reaction. So I'm going to go ahead and put, for the reaction type, I'm going to put DR for double replacement. But I'm not going to write in neutralization or precipitation yet because I don't know which one it is yet. And we'll finish that once we complete the equation. So when we have a double replacement reaction, now we're going to use this to help complete our problem. So we know that in a double replacement reaction, what's going to happen is the compounds are going to switch partners. So you can either think of it like the cations are changing positions or the anions are changing positions. So for example, we can think of it like calcium and silver in our problem here are going to switch places. And that will put calcium with nitrate and it'll put silver with bromide. So that's what we want to do for our products here. The tricky thing is you need to think about your charges. So for example, and this you can do this if it helps you, but you need to think about what the individual charges are of all of these ions. So calcium I know is a positive 2 charge, 2 plus. Bromide I know is a negative 1 charge. Silver is a positive 1, and nitrate is a negative 1. And remember that those can all be found on your ions list. So I need to remember those when I come over here to write the products. So I know that with the new partners, calcium is now going to be partnered with nitrate. So I need to put calcium and nitrate together, but I also need to remember that calcium has a positive 2 charge and nitrate has a negative 1 charge. So when I pair them together, I need to factor that in. So I'm going to need 2 nitrates to balance the positive 2 charge of calcium. So remember to do that. I'm going to put nitrate in parentheses and then put a 2 outside to signify that I need 2 of those, of that ion to balance the positive 2 charge. So that's my first compound as the product. And then I'm going to leave space for the phase there. And then the other product is going to be the combination of silver and bromide. So silver is a positive 1. Bromide is a negative 1. So those are already going to cancel out. So it's going to become Ag Br. Remember, the cation always comes first. And again, notice because they have new partners here, it means that the numbers that they had on the reactant side, like it had Br2 before, that was because it was paired with calcium. You needed 2 bromides. Now that it's paired with silver, you don't need 2 bromides because the charges already cancel out. So just be careful of that. I'm also leaving space in the front of my compounds because I'm going to have to balance at the end of this. All right, so now we're to the point where we need to figure out the phases. Now, sometimes assignments will give you the phases in the question or in the problem, or they will give you hints. If not, you'll need to use your solubility table. So to get the phase of calcium nitrate, cations are on this side. So I find calcium and then nitrate. It says S, which be careful. S down here means soluble, which actually corresponds to the phase of aqueous because it means it can dissolve. So I'm going to put an AQ there. And then silver bromide. Here's silver. And bromide is this one. Sorry, you couldn't see that. So silver bromide is here, which is an I, which means insoluble, which means solid. So the phase is solid for AgBr. Okay. So now that we see what our products are, let me go back to the notes here, and we can actually figure out what type of double replacement reaction it is. So the 2 options are precipitation or neutralization. It's a precipitation double replacement if one of the products is solid, and it's neutralization double replacement if one of the products is water. So we just need to see if in our products we have either a solid or water. So we don't have water as our product, but we do have a solid. So that tells me that the type of double replacement we have here is precipitation. So I'm going to add a P here for our reaction type, double replacement precipitation, as it says to do up here. All right, and then the very last thing you want to make sure you do once you've completed the equation is to balance it. And again, there are other videos that go over more detail with balancing. If you want to watch those, I'll go over through this one pretty quickly. So I'm going to start with calciums. So I have 1 calcium on this side, 1 calcium on this side. Bromides, I have 2 here, and I only have 1 Br over here. So I'm going to put a 2 in front of AgBr. So once I put that 2, I'm going to follow it. So now I have 2 Ags. So over here I only have 1, so we need to fix that by putting a 2 there. And now that 2 is now affecting my nitrates. Remember to chunk those. So I have 2 nitrates now, and I already have 2 nitrates over here, so that looks good. And that reaction is now balanced. So number 1 is done. So we'll move on to number 2. So same thing. First thing you want to do with these problems is figure out what type of reaction it is. So we're going to go to our notes and try to match what we see here. So what I'm seeing 2 reactants. One of them is an element, and one of them is a compound. So we're going to go through our notes and try to find which type of reaction has 2 reactants. So not this one, not this, or this one has elements, not compounds. Not this one. Could be single replacement, right? So single replacement has 2 reactants. And in single replacement reactions, one of them is an element and one of them is a compound. And that looks like what we have here. All right. So again, like with number 1, there's 2 different types of single replacement, just like double replacement. So I know for sure it's single replacement, so I'm going to put SR. Now to figure out whether it's cationic or anionic, you actually just need to pay attention to the element. The element, the reactant that's by itself, will tell you if it's cationic or anionic. So here, our element is aluminum. So you just need to figure out, is aluminum going to become a cation or an anion? Well, since aluminum is a metal, it's going to become a cation. So that tells us we have a cationic single replacement reaction. So I'm going to put a C there, single replacement cationic. And what that means is aluminum is going to switch places with the cation in the compound, which in this case is copper. So aluminum's going to go in, swoop in, right, and steal the date. So they're going to switch places. All right, so to complete this equation, if aluminum and copper switch places, copper now becomes the element by itself. So it's now just going to be copper by itself, just the element, no charge. This is just the element copper. And so when you, actually we'll do phases later, I'll just leave space. So plus, and again, now I need to think about aluminum is now going to pair with chloride. So aluminum, when it becomes an ion, that's going to have a +3 charge. And I know chloride has a -1 charge. So when chloride was with copper, this is copper 2, you had 2 Cls, but now when you're going to pair chloride with aluminum, we're going to need 3 Cls to balance the +3 charge of aluminum. All right, so those are our 2 products. And let's get our phases. So copper is just an element, and to get the phases of elements, you just check your periodic table. So copper is a solid. And then for aluminum chloride, we're going to check our solubility table. So aluminum chloride says S, which means soluble, which means aqueous. And remember, the compound of single replacement, the products of single replacement reactions, the compound will always be aqueous. This one you'll have to look up for the element, but the compound will always be aqueous. So now the last thing to do is to balance this. All right, so starting with aluminums, I have 1 Al over here, 1 Al over here. Coppers, I have 1 Cu here, 1 Cu here. Cls, I have 2 here, and I have 3 over here. Remember when you have that 2-3 combo, you want to make them both 6. So I'm going to put a 3 here, and then I'm going to put a 2 here. So now I have 2 times 3 is 6 Cls on this side, 3 times 2 is 6 Cls on this side. But doing that, remember, I just changed a lot of other things too. So now I have 3 Cus here, so I'm going to need to put a 3 here to fix that. And I have 2 Als over here, so I'm going to need to put a 2 here to fix that. And that is number 2. All right, moving on, let's check out number 3. So again, just like the first 2, always what you want to do first is look to your notes, assess what you have, see what it looks like, to figure out what you need to fill in. So for this one, it's a little bit different. We don't get any of the reactants here, but we do get a product. And the thing to understand is that we get 1 product. So when you go to your notes, you want to find the type of reaction that only has 1 product. And there's only 1 type that we learned that's like that, and that is synthesis. Synthesis reactions will only have 1 product. And the reactants, they always are made from simpler substances, usually elements. So if you were to predict the reactants here, what you're going to do is take all the elements that make this up, and those are going to be your reactants. Any element that's in here, you're going to list those out as your reactants. All right, so I know this is synthesis, so I'm going to put an S here. And I just need to inspect this compound and see what elements are in it, and those are going to be our reactants. So I see potassium, so I'm going to list that. Leave some space for the phase. I see carbon, so I'm going to list that. And I see oxygen. Now be careful with this, because oxygen is a diatomic element. So when I list oxygen over here, I need to make sure I put O2. And that would be the case with any diatomic element. Okay. I just want to note too, because you'll see this other type of reaction in the homework too. If this were a decomposition reaction, you know that because it would only have one reactant. And it's the exact same as synthesis, but just reversed. So just like what we're doing here, you could flip that, and if you were only given one reactant, similar to down here, number 6, that would be decomposition, and then you would list the elements out as products. All right, so let's finish up number 3 here. We just need to get the phases of these elements and balance it. So potassium is a solid. Carbon, also a solid. And oxygen is a gas. And the last thing we'll need to do is balance this. And the first thing my eyes go to here is another one of those 3-2 combinations. So you can see oxygen has a 2 here, and oxygen has a 3 here. So we just saw this in number 2. When you see that 2 and 3 on either side of the arrow, remember you want to make them both 6. So to do that, I'm going to put a 3 here. So 3 times 2 will give us 6 O's on this side. So to get 6 O's on this side, I'm going to put a 2 here. So now it's 2 times 3, 6 O's here. Now by putting a 2 there, I'm also affecting the K's and the C's. So 2 times 2 is going to give me 4 K's. So I'm going to need a 4 there. And then 2 C's. So I'll put a 2 there. And that is it for number 3. All right, so we're going to do one more. And it's going to be number 8 down here. So number 8, again, like always, the first thing you want to do is check your notes to see what this looks like. So I have a compound and an element. So I have 2 reactants, compound and element, which I know is like single replacement. It's very similar to a single replacement reaction. However, in single replacement reactions, the compound has to be an ionic compound. That's not what I see here. I see a covalent compound. So there's something a little bit off here, and if you keep checking your notes, there's a 5th reaction type we haven't talked about yet, which is combustion. Now, if you read through this, notice the example for combustion of a hydrocarbon here. This looks exactly like what we have. So in a combustion reaction, what happens is you have some reactants reacting with oxygen to produce energy and light. And combustion of a hydrocarbon is a very common example you'll see. So you can see here, and let me do it like this. So in combustion of a hydrocarbon, we're going to have some hydrocarbon. Hydrocarbon just means it has carbon and hydrogen. It may or may not have oxygen. That's why it's in parentheses. Reacting with oxygen to produce carbon dioxide and water. So look what we have here. Something that has carbon and hydrogen, a hydrocarbon, plus oxygen. And to complete it, it's as easy as this. If it matches that, the products will always be carbon dioxide and water. So I just get to write that. CO2, which is a gas, and H2O, which could be either liquid or gas, really. Depends on the temperature of the reaction. So that's it. The products are really easy once you determine its combustion. Once you know it's combustion, if it's this combustion of a hydrocarbon, even if there was oxygen in here, it's always going to be carbon dioxide and water. All right, so let's go ahead. Oh, and I need to label that. So combustion, we're just going to put a C. All right, and then we need to balance it, which can be tricky for these types of reactions. So you always want to start with carbon. So let me get my green pen. I have 3 carbons over here, so I'm going to put a 3 here. And then you want to go to hydrogens. Notice how oxygen's in a lot of stuff. Don't do that. Go to hydrogens next. So I have 6 here, 2 here, so I could put a 3, and that'll fix that. Now for oxygen, notice on this side, I have 3 times 2 is 6, plus the 3 here is 9. So on this side, I need to make it 9, but that's an issue because I have O2. So it's always going to be an even number. We talked about this in another video, but when this happens, actually this is part of your notes on balancing. When this happens, you want to go back and double all of your coefficients, except for this one. You haven't figured this out yet. Leave that, but we're going to double everything. So this invisible 1 here becomes a 2. This 3 becomes a 6. This 3 becomes a 6. All right, so once we do that, let's see if that helped. So everything else is still balanced. We just doubled everything. But now we have 6 times 2 is 12 O's plus these 6 to have 18 O's. So to make 18 O's over here, I want to put a 9. 9 times 2 gives me 18 O's. And that will balance it. All right, so that's a few examples, 4 examples, 4 different reaction types from your classifying equations assignment. Remember, when you do this, always classify first, figure out what it matches, then fill in the missing pieces, add your phases, and don't forget to balance.